Okay, so in the previous video, we learned about microencapsulation. So microencapsulation is basically divided into three parts. One is physical, another is physiochemical, and the third one is chemical. So in this video, we are going to discuss about the physical or physiomechanical microencapsulation. So it has 5 types. First one is air suspension coating. Now this particular question is usually asked for 6 or 5 marks. So if you remember the diagram and understand it, then you'll be able to write it down on your own in your own words. So let's start with the air suspension coating. So this one was given by Dale E. Worcester, and this one disposes solid particulate core material in airstream. Now the equipment capacity will be from 1 pound to 990 pounds. So this is the diagram. So here we'll be having the filters, and from here the air will go out. So this is the air outlet. Here there will be a Worcester tube. For the fluid to go out, we will be having a fluid nozzle. Instead of one, we are having 2 fluid nozzles. So this is a 2 fluid nozzle. Now here your coating solution will be present, and a peristaltic pump will be attached to it. Then from here the air will go inside. So this is the inlet of air, this is a heat exchanger, and this one right here is our bottom plate. So if you remember the diagram, you will be able to write it down and explain it more in your own words. Now we'll move to number 2, that is centrifugal extrusion. Centrifugal extrusion. Now this one in particular is only for liquid. You can also use slurry, but this one is for liquid form and the slurry form only. Now liquid encapsulation is done using a rotating extrusion head which contains concentric nozzle. Now here what are the requirements? So particles formed should be from 400 to 2000 mu m micrometer. This one will be having 16 nozzles. Now each nozzle has the capacity to produce 22.5 kilograms of microcapsules per hour. Now there will be a sodium alginate mixture which will be having bacterial cells in it. That will be attached with a peristaltic pump. There will be an air compressor present, and the spray nozzle will spray. And here a CaCl2 solution will already be present, into which these sodium alginate and bacterial mixture will be going. So this was your centrifugal extrusion. Now moving to number 3. Oh shit. Okay. So number 3 method is pan coating. So this is one of the oldest procedures that we use for formation of small coated particles or tablets. So here there will be a pan which will have a air atomizing nozzle. It will be so little and so fine. It will spray out the particles with the exhaust air. It will use air and it will spray out particles. Now the zone where it will be happening will be known as spray zone. This will basically rotate and spray coat. Now solid particles greater than 600 microns are considered for effective coating. So the size of the particles should be greater than 600 microns, then only you will get an effective coating. Now number 4 is spray drying. Spray drying is also known as spray congealing. Now here viscosity of solution should be as high as 300. Now there are basically 6 components in spray drying. So air heater, atomizer, main spray chamber, blower of fan, cyclone and product collector. Now let's understand this with the help of the diagram. So there will be your sample. It will be attached with a peristaltic pump. Then there will be a feed. Feed means from where you are putting your product inside. Now there will be first a drying chamber which will dry out the product. The drying chamber is attached with a heater, a fan and a filter. From the filter the air will go inside. So here an inlet of air will be present. Now the drying chamber is connected with our cyclone. So this is our cyclone. This is our cyclone. And the cyclone is attached with the filter bag. And from here the outlet will be present for the gas. And below the bag filter there will be dust present. Now here the flow of air is of 3 types. So number 1 is co-current. Co-current means your particles and the air flow, they are both in the same direction. So if they are moving to right, both of them are moving to right. If it's left, then both of them are moving towards the left side. Another is counter current. So the particle and the airflow will be opposite to each other. If the particles are moving towards the right, then the airflow would be towards the left. Third is mixed flow. So they will be moving on both the sides, right also and left as well. And the fifth and the last one is the vibrational nozzle. So here you have to remember 2 things. Number 1 is the droplet size will be from 100 to 5000 mu m. And another thing is the diagram of it. So there will be a motor, and the motor will be attached with 2 wires. These wires will be known as rotating cutting wires. So they'll rotate round, they'll rotate. And on the other side there'll be a nozzle present, to which there'll be a fluid jet which will dispense the particles. Now the rotating cutting wires will move so fast and they will cut the particles, and there'll be a bead formation. So this was the vibrational nozzle. So I hope you understood all of it. Thank you for watching.